Now we could have started by partitioning the y interval. So again, we're going to pose the question, what if the y interval is partitioned first? Then our outer integral is going to be a y integral, our inner integral is going to be an integral with respect to x. If the first partition was done with respect to y, then we would start out with partition 0 less than or equal to y less than or equal to 3, because of course on this semicircle the maximum y value is 3. That's going to give us a jth interval with a sample point y sub j star somewhere within that interval, and we have to ask ourselves, what are the x limits within the region? Because of course we're going to be considering a thin strip defined by our y sub interval, and that strip will have a direction, it'll proceed in the x direction, and we need to know where it starts and where it stops. So what's the interval from here to here, because that's the interval we're going to have to partition with respect to x. Now again, we could use geometry, considering this triangle, which I seem to have not drawn very well, but we consider this triangle. We have 3 here, we have yj star here, so up here we have square root of 9 minus xj, star, xi star. That's this distance, so that this x coordinate would be 3 minus the square root of 9 minus xi star. Alternatively, we could solve x minus 3 squared plus y squared equals 3 squared. For x, we have x squared minus 6x plus 9 plus y squared equals 3 squared, so that x squared minus 6x equals y squared. This wouldn't really be the best idea, because of course now we have a quadratic to solve for x. It would really be easier just to take the expression here and say, well, okay, let's see, x minus 3 squared equals 3 squared minus y squared, so that x minus 3 equals plus or minus the square root of 9 minus y squared, so that x equals 3 plus or minus the square root of 9 minus y squared. And that solution would give us both of these points. In any case, what we end up with is that for sample point yj star, we have to partition the interval 3 minus, well, hang on a minute. Okay, I've just blocked that with the domino, but the interval 3 minus the square root of 9 minus yj star squared. And I've noticed a careless error up here. This is not xi, it's a j and it's a y. It's a yj squared. That looks pretty bad now, but it's a yj star squared. Wrote it down carelessly here, but clearly if your hypotenuse is 3, your side is yj star, then this side is the square root of 9 minus yj star squared. This point is then 3 minus that distance, and everything's symmetric. We could set up a similar triangle over here and we'd get the same solution for the length of this side, but that would be added to 3, so that we're partitioning the interval from x equals 3 minus that square root to 3 plus the square root of 9 minus yj star squared. This leads us to the integral first outer integrals from 0 to 3, because we started by partitioning the entire y interval, and that's going to be with respect to y, and then we're going to have to integrate over this strip with respect to x, so that's going to be the integral from 3 minus the square root of 9 minus y squared to 3 plus the square root of 9 minus y squared of our function f of xy dx, where again our f of xy simply depends on what quantity it is we're trying to find. So if we partition x first, we get an integral in this order, a y integral inside of an x integral. If we partition y first, we get different expressions, different limits, with an inner integral on x and an outer integral on y. Both partitions, both sets of limits define the same region. In both cases, the region is this upper half circle. We could describe that by 0 less than or equal to x less than or equal to 6, and then for given x, 0 less than or equal to y less than or equal to the square root of 6x minus x squared. Alternatively, the region is 0 less than or equal to y less than or equal to 3, and 3 minus the square root of 9 minus y squared less than or equal to x less than or equal to 3 plus the square root of 9 minus x squared. This description leads to this integral, x going from 0 to 6, y going from 0 to the square root of 6x minus x squared. This description leads to this integral, y going from 0 to 3, x going from 3 minus the square root of 9 minus x squared to 3 plus the square root of 9 minus y squared.